Hey guys, welcome back on this rainy morning. It has been raining here a lot for the East Bay, at least I think so. I'm not from around here, so I don't know if this is normal, but since moving out here 5 years ago, this is the most rain I've seen. Alright, this is an odds and ends video. We'll test out the strength of this binder, and after that do some practice TIG welding. I was thinking to simply tighten the vise on the binder, but to better simulate the situation, we need to get a seat post in there. A regular post won't fit, so I'm turning down this cutoff from another seat post. I don't know where it came from. I think it came from the one that I put on my last build. I tried sanding it first, but I need to remove more material. In the lathe it went. I finally made a new tool from High Speed Steel, and I ground an A-bomb style chip breaker on the tip of the tool, but I think it needs to be closer to the sharp end because it's not working so well. I think it needs to be a tad closer. You're not supposed to like get it right up against the end. You're supposed to leave a little space, like a little flat area, but I think I left too much. Alright, ready for the first test? I'm just gonna stick it in the vise like this and apply a normal, or try to simulate a normal amount of pressure, and put just enough to get this tube to the seat tube to not turn. So there I am, applying just a normal amount, kind of wiggling it with my hand, or trying to wiggle it loose. Now I got the pipe wrench out, and I'm gonna try to turn this thing, see if I can get it to move. And I'm putting a pretty good amount of pressure on there, quite a bit, and I could not get it to move. So I think under normal circumstances, this binder would do just fine. But there's people out there who over tighten these things, and that could be considered a normal circumstance as well, because that's, you know, just a general user would probably do that. I stuck it in the vise this way to try and get better leverage on the part that's closer to the tube, and not a really good test at this point because you can see the end of the binder, the slot is it was touching, and here I am whacking it with a hammer and it just wiggled loose. So I cut a larger slot, and now I'm tightening it as much as I can. Now I'm actually trying to break it, and I broke it. And the expected result. So this test wasn't scientific in any way, but it did give me an idea of how much pressure the binder can withstand. If a person were to tighten the binder, like excessively, tightening it with like a wrench, I think they could probably get this to break. A better test would have been to drill a hole and tighten it normally with a screw. I still have more brazing tests to try later on. Not in this video, but sometime in the near future, I'll show you guys a strength test by tightening the binder in a more realistic scenario. On to TIG practice. This is something I should be doing on a regular basis, but I haven't. I always seem to practice before I have some upcoming welds to make, and that's not good. I haven't really improved since the last practice, and to really improve, I need to put in the hours. I will say that I've been experimenting a lot, and I finally feel like I've got a good understanding of why things go wrong when they do. Sometime I'll do a comprehensive video on all the stuff I've learned since starting. Okay, I'm using an 035 ER70S2 filler rod. To better simulate heat dispersion, I use a basic heatsink made of turned down aluminum. And I picked up a Furick Fupa, I don't know if you pronounce it that way, number 12 cup kit. That is attached to a number 9 size torch, and I'm running a 1/16 inch tungsten. I'll be pulsing at 120 amps, around 1.5 pulses per second, 5% background current, 25% pulse time on, and argon flowing around 18 CFH. The biggest problem I have is getting my torch angle to follow the curve of the tube. This is still like a major problem I have. The dark blue area at the start of the weld happened because of my torch angle. On to the other side. The filler balled up, so I stopped immediately. I think it's better to stop and start again when this happens. Make sure to cut the ball off the end so that you can start nice and fresh. You can see the filler balled up twice at the end, but I kept going for some reason. And when you do that, your welds will look like this. This is a really short one, but it came out pretty nice. I stopped because I knew my angle was bad and it would stop balling, so I just stopped. Now I've got the camera pulled out so you can see me trying to get my torch angle to follow the tube. You'll notice nearly all my welds end with the end of my filler balling up. In the past, I used to think that maybe it was due to incorrect pulse settings, but now I can tell you with near certainty that it's all about the torch angle. So if this keeps happening to you, just work on that torch angle. Going one size up with your filler is much more forgiving to your torch angle, and I do that sometimes, but I know 035 filler works just fine with pulse if you're doing it right, and I'm determined to get it right. You can see where I had a bunch of start and stops. Some folks like to pulse faster, some slower. It's kind of a matter of preference. You'll know if your pulse is too slow, if your heat affected zone is too large. I could probably pulse faster, but if you're learning, I recommend choosing a slower pulse, one that won't burn the tube, and sticking to that until you get comfortable and your welds are consistently looking good, and then you might want to consider moving on to speeding up your pulse. Basically, fix one problem at a time is my advice. Each practice session, I try to focus on one problem at a time. Here I am experimenting with the crazy way to hold the torch, and I gave up on that really fast. I've got a lot of flaring going on at my starts, like scratchy starts. This will happen if your tungsten is too far away from the work, if your tungsten is a nub and it's not a point at the tip. And it can happen, I think, if the tungsten gets all scratched up on the sides, like if you were sharpening it and accidentally ground the side of it. Okay, this side came out worse. You can see I was going slower and the dimes are stacked close together. This came out pretty good. Looks out of character with my usual welds though. I generally don't stack this close together. And I'm not sure what happened here. It's very likely that my scratchy starts caused this. The arc probably jumped onto the side and made this little burn mark. Alright, practice session over. And here's what we've got. Lots of starts and stops. There's a short one right there. And there's that in the corner there, it's not happy with that at all. A lot of starts and stops again. I think that's where it kept balling up. And then as you kind of come around to the top flat part, where it starts out there, it looks pretty good. And then those flat parts, I still need a lot of work. And then coming around again. And again, I think this area had a lot of starts and stops. At least it looks that way. And finally, that part doesn't look too bad either. But yeah, I clearly need a lot of practice. And I need to do this on a more regular basis. Alright guys, that's all for this video. I hope you guys found this useful. And if you're having trouble, just keep at it. I know it can be frustrating, but when it does get frustrating, just try to focus on improving one thing at a time. You guys know I've been practicing a while now for my earlier videos, and the truth is I haven't improved much. The reason for that is I haven't been practicing. You gotta practice on a regular basis, and I need to put in those hours. It's as simple as that. Alright guys, hang in there, keep on practicing, and I will see you in the next one. See ya!